Concept Overview illustrates the proposed OPIC-based ROF network, comprising the NC unit at the CO and the two wireless end users communicated with the respective routes, which in turn are connected with the CO via fiber. Users A and B transmit their packets to the routes, where they are converted to SCM optical streams through the modulation of the laser diodes, LDs, coupled together and forwarded to the CO through the optical media. The physical layer all-optical XOR encoding operation is performed on the fly at the CO and the resultant signal is broadcasted back to both routes, demultiplexed from the uplink traffic and converted from optical to electrical, OE, by means of a photodiode, PD. The electrical encoded signal is transmitted from each route to the respective wireless user in order to be decoded. Each user recovers the bit sequence originating from the other user by performing a second XOR function between its own locally stored data and the received NC encoded data. In this way, the OPIC technique implemented at the CO is capable of encoding information coming from users located in different cells, which is not feasible with current wireless NC schemes. All-Optical Digital Network Coding, NC, scheme at the central office of ROF networks. A. Depicts the frame scheduling in an ROF network where no network coding is employed, as well as the frame scheduling in an ROF NC-based communication scheme. In both cases, it is considered that for the uplink, route A and B transmit data packets modulated on the wavelengths lambda 1 and lambda 2, respectively, while for the downlinked traffic, the CO uses lambda 3. When network coding is not employed, routes transmit data A and B to the CO during the first time slot, while the CO receives both packets and forwards packet from user A to B and packet from user B to A, using two successive time slots. When network coding is applied in an ROF network, then the CO encodes and broadcasts the NC encoded packet to both users in a single time slot, occupied only two time slots for the uplink and downlink traffic. This concept exploits the preamble and postamble of the frames for packet order resolving in case of non-synchronized packets. B. Shows the encoding and decoding operation when packets from user A and B reach the encoding unit at the CO bit level synchronized or with a time delay equal to delta t, asynchronous operation. In the case of synchronous operation, data from user A and B are digitally encoded by means of a SOA MZI XOR gate and broadcasted to both users. Each user recovers the packet of the other user by performing a second bitwise XOR operation between the received encoded signal and its own data. Considering that the end users are wireless clients that may reside at different distances from their respective routes resulting even to sub-bit time mismatch between the two packets reaching the CO, it is critical for the OPIC scheme to operate also for asynchronous data. A. Frame scheduling for ROF network, without network coding and with a proposed OPIC scheme and, B. Conceptual encoding and decoding operation for synchronous and asynchronous data with a time offset of a sub-bit delay delta t. As shown in B. During asynchronous operation, a sub-bit optical pulse with duration equal to delta t is generated in the encoding packet. However, the final decoded packets from the second XOR operation can still be correctly recovered by both end users through a second XOR operation, without any data loss.